Hey everyone, welcome to discussion number three's mini lecture. So today we're going to be covering exploratory data analysis or EDA, data cleaning, and just some general concepts to think about when you're looking at new data. So we'll start off with a slide that's partially from lecture about granularity. So whenever you look at a new set of data, a new data table, data frame, a really important thing to think about is granularity. What does each record or what does each row in your data represent? This is very important to determine what your analysis is going to mean, what analysis you are going to be able to do. And so you really want to look at each row. What does each record or row in your data table represent? The more fine-grained it is, the smaller unit each record represents. So in this example here from lecture, if we have like each row representing a single student, so to say. Let's say we have 3 different students and each row of our data table represents one of those students. We could consider this fine-grained. If, let's say it's looking at like their average grade. So we have the average grade of every single student. In the middle, we could say if it were going to be a little more coarse-grained, less fine-grained, we could have each row represents maybe an entire grade. So this could be like 6th grade, 7th grade, and 8th grade. Each grade is represented in a row, and we have the average, their average scores for the entire grade. If we were going to look at an example of coarse-grained, this could be like entire schools now. Each row represents a single school, right? This isn't like an aggregation of many students, right? Many grades, 6th grade, 7th grade, 8th grade, for example. And this is something that you'll be asked to notice or look at and identify what the granularity of a data set is. So we just want to know, what does each row represent, whether that's a person, a purchase, a group of users. And if the data are coarse, right, how did they aggregate the records? Did we, take the average of all the students' grades? Did we take the median mode? So it's important to think about that as well. Oftentimes when we get data in the real world, it is pretty messy. It's not super clean. We can say like it's dirty. And one of the main challenges that we'll talk about in this mini lecture is how to deal with missing values. So what to do when you have pieces of your data missing. What strategies are reasonable in this case? Basically, the answer to that question is whatever method preserves the distribution of the original data. So we want to keep the distribution similar, right? So if our data, let's say we have a bunch of students' grades in English right now, right? So let's say like the distribution of the data, we make a histogram of the data and there's a lot of data, like maybe it's like a normal distribution, a lot of grades in the middle and then some low grades and some high grades. That's the current distribution. When we think of a strategy to fill in our missing ones, right, the missing grades, the idea is that if we were to plot our distribution again, it should look fairly similar. We're trying to keep that distribution and not really change characteristics of the data overall. So one option, right, that we talk about in this class is imputing missing values with an appropriate number. So we like fill in the missing values somehow. Maybe we fill it in with the number 0. Maybe we fill it in with the mean, the median, the mode. It really all depends on the distribution of the data, and you'll get some practice with this in discussion to think about like which of these options or potentially other options would be a good idea if you were imputing missing values. So you look at your distribution and think about, oh, if I filled in all the empty values with this number, some number, would it change my distribution? Would it keep it the same? And then you assess that way if it's a good strategy. Another option is to drop missing entries entirely, like we just drop all the students that don't have the grade listed. This is, it could work and it might not work. And the main thing you want to be is cautious. You only really want to consider this if you don't have a lot of missing data. If you only have like a couple of records where there's missing data, you could consider that. You want to really keep dropping stuff to a minimum. Yeah, okay, let's continue. So let's move on to variable types, right? This is another thing you want to think about when looking at your data. So the main 2 categories we have are quantitative and qualitative. Quantitative, right? Quantities, numbers, that's normally what you want to think of. The idea is that these numbers have a very numerical meaning, that the distance between the numbers, the intervals or the distance between the numbers means something, right? It's different to be 0.5 milliliters different versus 0.05 milliliters, right? There's a difference there. Intervals have meaning for quantitative variables. So the example we looked at here, right? Milliliters of your drink, your cup of boba, or the number of pearls in your cup of boba, right? Kind of like some sort of counting or measurement usually is what falls under quantitative. We won't be super specific about differentiating between continuous and discrete this semester, but the idea is just, you should be able to identify that this is quantitative. Then we'll look at two types of qualitative variables. So qualitative qualities, right, categorical things. So the most straightforward one is nominal, right? Things that are like names of things, name, like boba stores in Berkeley. We have Rarity, Happy Lemon could be like names, like my name, other students' names, your name. The main thing here is that they don't have like an inherent order to them. There's not really a natural ranking that really just like inherently comes with these names. On the other hand, right, we can have qualitative ordinal, which does have an order. So this could be like a 5-star review system for restaurants where 5, right, is like the best and then 1 is the worst, but it is still very qualitative. It's about like how good the food is, and not necessarily an actual like mathematical measurement or counting of sorts. It's more quality based, categorical. Okay. The last thing we're going to talk about are primary and foreign keys. So a primary key is the smallest set of columns that uniquely identifies each row. That means like a set of columns where no 2 rows has the same values in those columns. So in this student's like a data frame here, this example, that primary key would be the student ID, right? No 2 students has the same student ID. It's unique for every single row. So we would consider the SID the primary key for students. Then for the department's data frame, right here, we're looking at a data frame that shows all the different major departments at Berkeley. The smallest set of columns that uniquely identifies each row in this case would be the major column because each major only has 1 row in this data frame. We don't have 2 rows for any major. And you'd want to know, right, like the number of students could be the same for 2 different majors, right? The home building could be the same for 2 different majors like data science and CS or both in SOTA, right? So both of these could not be the primary key on their own, at least. But the major, right, given what we know about what this data frame holds, it makes sense for that to be the primary key. An interesting thing to note, right, is that sometimes the primary key is more than 1 column. Maybe like 2 columns together give you a unique identifier for each row, whereas just 1 wouldn't. And so you'll see practice of that during the semester. The last thing we're going to talk about are foreign keys. So a foreign key is 1 or more columns that reference the primary key of another table. So major is a foreign key of students because it references the primary key of departments, right? So I can look at, URSA studies here for student OSCE, and I can connect this URSA study to look at the department's table and find more information about URSA studies that applies to this OSCE student. The foreign key is the column, right, where it references a primary key somewhere else. All right, so I hope you all have a good discussion number 3. You'll probably do some more pandas practice as well. And feel free to come to office hours if you have more questions. Okay, thank you.